Jaw plant setup. The intent of this video is to go through what is required to ready this plant for work. Before your CEC jaw plant arrives, you need to have the blocking package of support timbers as recommended by CEC on site. First, move the plant to a level, compacted, stable operating site. Place the machine so its feeder is as close to the feed source as possible. This placement increases production by shortening the loader changing cycles. Now that we're at the hypothetical operating site, put a block under both front hydraulic setup legs. Note, the jaw plant is electrically operated and has a 150 horsepower drive motor. The electrical panel rides to the work site on the crusher. When in use, the panel sits on the ground next to the plant. All the motors stay connected, and you only attach the electrical line from your power source. Set the legs down until you can release the delivery truck from under the plant. Once the truck is gone, bolt on the front support legs and their braces. Next, place blocking under the rear hydraulic setup legs. Raise the rear of the plant to give you future conveyor drop clearance. Level the machine left to right, then raise the front legs to level the frame front to back. Now place cribbing block under all support jacking legs and under the front support legs. Use your hydraulic legs to raise the plant while adding the blocking. Be sure that your plant is level front to rear and side to side. This will help ensure the material will flow properly, the feeder will feed evenly, and the jaw plant will feed and discharge properly. Now let's look at what we've done. The crusher is blocked in the rear, in the front, and behind. It's also blocked at the end of the feed hopper. This allows for proper machine operation and material flow. Next, we need to lower the under conveyor to provide 18 inches of additional clearance between the jaw and the discharge belt. This provides additional room for the rebar in the product to turn. Then, add the conveyor space panels, one on each side, and also the rear panel. Adjust the skirt board rubber to stop rock leaks. Now look at the feeder. You need to remove the spring suspension transportation lock before startup. The lock keeps the feeder rigidly in place and overcomes its normal spring suspension. After you finish blocking, you need to inspect the machine to be sure that nothing has been inadvertently stored or has accidentally fallen into the jaw. Make sure the chamber is clear. Check your adjustment to be sure that the jaw dies are positioned to produce the product you intend to make. Look in the feed hopper to be sure that it is also clear. If we were going to operate the plant, we would remove the electrical panel and attach our power source. Next, we would fold out our discharge conveyor to the working position. You're now ready to test run the jaw plant. Start the plant, and you're ready to start crushing. Load the feeder, and begin your crushing. Total setup time is just 3 to 5 hours, depending on crew size. Clutch adjustment. CEC sells machines that have diesel engine drives with multi-plate disc clutches. These clutches need to be operated properly and adjusted regularly. Let's discuss these needs. Clutch operation. When you are going to activate the clutch, you need to reduce the engine RPM to 1000 RPM. Next, do not lock the clutch in without following this procedure. Partially and momentarily engage the clutch to start movement of the crusher. Your crusher may be a jaw or impact crusher. Both types of crushers have very heavy crushing members and need to be handled in a similar manner. Re-engage the clutch several times. Raise the crushing member RPM toward its working speed. When you have raised the speed of the crushing member to a level that does not lag the engine down, engage the clutch fully. Next, increase the throttle setting to the full working RPM. High RPM engagement and direct full engagement of a clutch will cause almost instant failure. Clutches are not forgiving, and CEC does not warrant misuse. Clutch adjustment. All clutches that are used by CEC on their crushers require regular adjustment. A new clutch needs to be adjusted to its proper torque setting before being put into service. Every clutch has a setting range that needs to be strictly observed in order to operate properly. Normally, the cover plate of each clutch gives you the torque setting for this particular clutch. You need to be sure that you follow these settings. In order to make a clutch adjustment, the machine must not be running. Always have the clutch disengaged during adjustment. Remove the clutch inspection plate and read the setting requirement on the plate. Use the settings listed on the plate rather than what the manual may say, as the plate settings are for this specific clutch, and the manual may cover a different type of clutch. However, if you have contradicting specifications, you should verify the setting with the factory. You need to refer to your manual for the step-by-step procedure of proper clutch adjustment. We're going to show a clutch that we have in the CEC shop today. This will give you the procedure, but does not take into account the differences in the release method of clutch adjustment rings. There are two common release methods for adjustment rings: push-pin release and the cam overlock. We're going to demonstrate the cam overlock. You use a screwdriver to release the cam lock. You then use a pry bar to adjust the locking nut. Upon completion, you release and relock the cam lock into the adjusting nut, and then move the nut to make sure you are locked. The push pin works the same, except you pull the pin to adjust and push it back to lock. After adjustment, use the engagement lever and engage and disengage the clutch 4 times without the engine running. This allows the clutch to accept its new torque setting. Torque adjustment is the only way to check a clutch to assure it is set properly. Now, place the torque nut adapter over the clutch operating shaft. Place the torque wrench over the operating shaft adapter nut. Stroke the torque wrench and measure the foot-pounds of torque it takes to engage the clutch. Compare the measured foot-pounds of torque to the specifications on the clutch plate. If they are proper, you have completed the adjustment. If not, reset the adjustment to the proper foot-pounds. Recheck to ensure the locking pin is in place. Reinstall the clutch inspection plate. Remove the torque wrench and torque nut adapter. Reset the torque wrench to 0 for storage. Follow the maintenance manual for frequency and use the feel of the handle pressure as an easy alarm for resetting. A new clutch needs to be checked daily with a torque wrench and adjusted each 10 hours for the first 50 hours of operation. CEC is providing you with a suitable torque wrench for this clutch. A clutch usually needs readjustment weekly after the initial break-in period. Some operation requires more frequent adjustment. Use your torque to establish the frequency needed for your operation. You must follow the procedure as we have outlined it if you expect normal clutch life. CEC does not warrant misadjustment or misuse. Engine-driven generator drive adjustment. The generators on the CEC impactor plants are belt-driven from a front-engine drive pulley. Always adjust with the engine stopped and the key in your pocket. A cogged belt is used to transmit the power from the engine to the generator. We're showing you how to loosen the generator and readjust the drive belts. You have the following components to work with. 4 bolts that lock the generator down to the frame. 2 pusher bolts that tension the drive belt. A turnbuckle that stops the generator from rotating around its center axis. To adjust, loosen the bolts on the base slightly so that the generator can move back and forward. Use the adjusting bolts to tighten the drive belt. Tighten the turnbuckle to reduce the belt slack. You should only have 1/8 of an inch of slack in the belt. Measure the base to make sure your belt and sheaves are running square. Retighten the mounts. Check the bearing bolts on the engine drive to make sure they are also tight. Replace the belt guard. Jaw crusher adjustment. CEC's jaw crusher adjustment is done in the same manner whether it's the 20x30 jaw or the 40x60 jaw. Common items found on CEC jaws are as follows. Side-mounted wedge releases for the toggle plate. Dual toggle rods. Adjustment shims for sizing. Hydraulic cylinder to move the toggle block. Standard and long toggles. Now, let's take a few minutes to learn how to change the setting of this jaw crusher. First, we release the toggle block wedges by compressing the center bolt, forcing the 2 wedge support bolts inward, and releasing the toggle block locking. Measure your toggle rods. If you're adding a lot of closing shims, you'll need to move the toggle rods out in length by the amount of the shim to be added. If you don't, you can't get the shim insertion space needed. The reverse is true if you're opening the setting. Add shims to reach the jaw setting required. A standard full set of shims is included with your CEC crusher. You can use your measuring tape to adjust the toggle rod length. You'll need to snug these up when operation begins. Take the slack out of the toggle-to-toggle seat. When they're loose, you'll hear a banging noise. Normally, there is about 3/8 of an inch between the spring coils when at the proper tension setting. New jaw crushers need the flywheels tightened. CEC has a tapered flywheel bore, tapered shaft, shaft to flywheel keg locking ring, and shaft nut. The nut needs to be set with the wrench provided by CEC and a 16-pound sledgehammer. You need to recheck the tightness after running 3 different times the first week. Always bend over 2 of the locking ring teeth to provide positive locking of the flywheel nut. You need to check the jaw die bolts, Pitman protection bolts, and cheek plate bolts for tightness before startup. This will need to be repeated 3 times in the first week. Any retainer bolt head that extends above the dies needs to be ground off flush before startup. Failure to do this will cause the retainer bolts to break. The toggle plate is the lower pivot plate of the jaw crusher. Its location provides a secondary nip on the return stroke of the jaw and crushes elongated rock, providing uniform throughput. The toggle plate extends from its seat on the toggle block to the machine seat on the back of the Pitman. It pivots on machined, replaceable, bolt-in seats. These are the wear surfaces and will need to be replaced from time to time as use requires. The toggle is the jaw crusher's safety fuse. When you put an oversized, uncrushable item in the jaw, the toggle plate, by design, will break in the center, providing the needed relief and crusher protection. CEC jaws need lubrication. They have 2 separate lubrication needs. The shaft support bearings, located in the frame cap, run in 80 to 90 gear lubricant. They are to be checked daily by their individual dipstick. The top of these dipsticks are normally painted red. The Pitman has a sight gauge in the backside and needs the oil level to be maintained in the center of the glass. It uses the same oil as the outside bearings. The bearings are dust protected by labyrinth grease seals to stop dirt from being able to reach the bearing. There are 2 groups of 3 each grease fittings that require greasing every shift. Refer to your service manual for the proper grease for your climate and season. Vari drive adjustment. The Vari drive is a mechanically adjusted belt and variable sheave arrangement that provides 35% speed adjustment between the slowest and the fastest speed. The slow setting is just above the critical path of the feeder vibrator head. This system gives you the capability of running from very slow to maximum feeder output, allowing you to work at any point in this speed range that the product lump size and crushability of the product allow. Let's take a moment to look at the adjustment of this mechanism. You need to load the feed hopper completely full to provide a medium point for the feeder drive side belt adjustments. Next, you adjust the pivot table L bracket to tension the feeder drive belts to a normal drive tension. This adjustment is done by loosening the 4 mounting bolts and tensioning with the adjustment screws. The feed table should be horizontal to the feeder's floor. You need to tighten the top adjusting spring on the table to set this position, along with sliding the L base on its 4 bolts. Doing this will provide proper tension. Retighten the mounts. To adjust the feeder limit switch, you start out at full speed position with the feeder drive turned off. Adjust the limit switch to disconnect the forward power at that point. The belt will be 1/2 inch from the top of the sheave. Next, you turn the feeder speed down to its lowest RPM by using the speed range buttons. Adjust the lower limit switch. Note, the feeder is still turned off. All feeders have a critical range within which they will not run smoothly. Never adjust the feeder into the critical path range. You can tell the critical path because the feeder will become very uneven and rough in its cycle. The motor will not move more than 3 inches total. Readjustment will be required because of initial belt stretch. Check daily for the first week of operation. Call CEC Direct if you experience a problem or have a question. There are hundreds of these Vari drives running, and they all work extremely well. Jaw Plant Belt Drives. Jaw crushers, their feeders, screens, and conveyors are all belt-driven. Belt drives will stretch 3 to 4% of their length during their useful life. This means that you need to adjust the belts regularly. Belts stretch most in their first 100 to 150 hours of operation. Adjust them every 10 hours for the first 50 hours of operation, and adjust them to your manual specifications. If you choose not to adjust the belts, you will experience belt stall when the crusher is loaded. This is going to cost you more in time and trouble than doing the adjustment. After the belt break-in time, check belt tension weekly to make sure the tension is proper. Never adjust the belts when the machine is running. You could be injured. Reinstall all guards when the belt adjustment is finished. Safety first is CEC's goal. Let's look at one of your crushing plant's biggest problems: belt adjustment, belt training, and skirt board adjustment. Let's take a conveyor and walk through the proper sequence of setup. First, we need to adjust the feed box skirt boards. These need to have a clearance of 1/16 inch between the belt and the skirt board. A hacksaw blade is a great gauge. If the skirt boards are too tight, we get welding, which causes bad belt tracking and over horsepower use on the drive motor. Next, tension the belt. Remove the lower side guard to gain clear access. There should be normally 3.5 inches to 4 inches of belt sag between the return idlers. The idler needs to be square to the conveyor frame. The head and tail pulleys also need to be square to the conveyor frame. The tensioning is done by the bottom belt adjustments on the standard conveyors. Replace the side guards when adjustment is complete. Belt tracking is accomplished by steering the troughing rollers. Advance the opposite edge forward to force the belt over and cause the belt to run true. Look up the belt and steer the roller like you were steering a bike. The belt will respond. The motor to gearbox drive belts will need adjustment. The standard formula for adjusting is to measure the belt centers. Example, 15 inches. Adjust the belt to have 1/64 of an inch of sag per inch of center distance. This works with all V-belts on conveyors and stackers. Note, CEC uses Dodge gearboxes on all conveyors and stackers. You need to check the oil level of these boxes before startup. Shipping on some conveyors requires the boxes to be without oil. Check yours before running. Consult your Parts and Service Book Dodge section for proper lubrication and oil level. Belt splicing. In order to help you learn new service techniques with a crusher and screen, we will show you how to splice a replacement conveyor belt. Measure the belt length or consult CEC for the proper lengths. Be sure you order the ends cut square to the side so you do not have to recut the ends, causing the belt to be too short. Open the belt ends up so you can work with them. Take one end, square the punching template to the belt, and nail it through to a 2x12 beam for support. Take your belt punch and punch the holes in the proper location. Note, this is very important. You must use the combination of proper tools when punching a belt. CEC uses 140, 150, and 190 Flexco fasteners. Use the proper 140 template, 140 punch, 140 fastener, and 140 tape size in order for your splice to be proper. You will need a tightener wrench and bolt breaker also. Repeat the punching sequence on the second end of the belt. Square the template and nail it down. Then punch the holes. Next, remove a troughing idler at a point where you're going to do the splice. Put a 2x8 across the frame so you have a working place. Thread the belt on the conveyor. Use conveyor clamps and cable come-alongs to bring the ends together. Install your proper-sized Flexco fasteners loosely, starting at the middle and working outward. Clip the corner of the belt to eliminate hang-ups. Install the joint tape. This runs completely around both sides of the belt splice seam. This seals dirt out of the splice and keeps the splice from rippling. Tighten the locking nut snug. Do not over-tighten, as it will cause the belt to create misalignment. Use your bolt breaker to remove the surplus length from the fasteners. Use a small air grinder to smooth the bolt-to-nut area. Tension the belt. Adjust the skirt board and train the belt to run square on the head pulley, tail pulley, and idlers. CEC manuals have a very good section on belt adjustment, training, and drive tensioning. Refer to these for additional information. Wrap drives are different. You only square the head pulley with the bottom adjustment. You tension the belt with the wrap drive adjustments. This gives you tension and increases the wrap on the head drive pulley. This allows additional horsepower to be transmitted to the belt, giving you more tons per hour. CEC belt speeds are normally 250 feet per minute, but this can be increased when job conditions require more tonnage. Improper belt tension causes the centers of head pulleys to fail. It is important to maintain proper belt tension to avoid this. In the event that you need to change a head pulley on a closed-circuit cone or impact plant with a wrap drive, you need to know how to do this without taking the belt apart. When a machine has a very tight belt, you may need to remove the wing tail pulley to gain enough slack for the drive pulley removal. Relax all belt adjustments to give you maximum belt slack. Remove the snubber pulley. This gives you about 10 inches of additional slack. Make up 2 spreader bars as shown. We recommend round bars for strength with welded-on washers. They need to be of sufficient length to allow you to clear the obstructions and get the come-alongs hooked to the bars. Insert 1 spreader bar above the head pulley. Insert the second spreader bar below the pulley. Fasten 2 cable come-alongs to the spreader with the pull-up and 2 to the other spreader with the pull-down. Tighten the cables until you've made enough room to remove the head pulley. Unbolt the drive, gearbox, and belts. Remove each of these. Unbolt the head pulley bearing on both sides. Now you can remove the head pulley. Reinstallation is the opposite procedure and will go more easily than the original removal. The complete procedure, including head pulley changes with the shaft, should not exceed 6 hours, with 2 men and a service truck with a crane. Call CEC if you have any procedure questions. We can help you. Tail pulleys are changed in the same manner, except that they do not have any drive components. Toggle plate replacement. The toggle plate is the pivot mechanism between the eccentric mechanism of the pitman and the jaw adjustment toggle block. The jaw is adjusted by shims placed behind the toggle block. The jaw comes with a standard shim pack that will allow you to go from fully open to its smallest setting. Shim installation. Release the toggle block locks. Hydraulically move the toggle block forward. Add or remove shims to adjust the jaw to your required setting. Hydraulically retract the toggle block against the shims. Relock the toggle block and locking bolts. Make sure they properly extend and lock. The high angle of the CEC toggle plate gives our jaw a secondary nip on the product pass through the jaw cavity at the exit point. This reduces the length of slabby material and gives you a uniform, controllable size. The toggle plate is the fuse in a jaw crusher. If you put a non-crushable item in the jaw that will not compress and pass the jaw setting, you will break the toggle plate. This is your safety fuse. Toggle plates are cast with a center stress point to make sure that they will break in an overload situation. Never make your own toggle plate from a steel plate unless you do not value your crusher. Toggle plate replacement. Let's assume we have a broken toggle plate and the piece went out the conveyor. The first step is remove the protection flap. Now move the pitman away from the toggle block. Do this by using a come-along hook around the toggle rod mount and to the crusher frame. Move the pitman out. Loosen the nuts on the toggle rods 1 inch. And then move the toggle block back. Remove some shims to give yourself hydraulic adjustment to lock the toggle block in place. Now that the pitman is forward and the block is back, inspect the toggle seat. The seat sets in a milled slot and has bar and bolt retainers to keep them in place. If they are not worn badly, reuse them. If they are worn and you're going to replace them, weld a steel stop that would control the pitman movement in the event that you had a come-along failure. You need to give safety protection to the mechanic doing this change. Now, move the toggle plate to the back edge of the toggle chamber. Use a webbed belt or chain to connect it to a chain hoist suspended from the jaw cross tube. Pick up the toggle, set it on an angle that will allow it to meet the seat angles, and lower it down. Place the leading edge of the toggle in the pitman seat. Elevate the toggle angle to meet the toggle block seat. By using the hydraulic, move the toggle block forward to connect the assembly. Remove the come-along and free the pitman assembly. Tighten your toggle rod spring to keep tension on the assembly. Reinsert your adjusting shims and reset the assembly. Retighten the toggle rod bolts and springs. You are now ready to go back to crushing. The jaw dies and the pitman protection plate, along with the cheek plates, are the crushing cavity wear liners. The parts are made of manganese and they wear harden to perform their jobs. The harder the rock, the harder the manganese liner becomes. The manganese shows a lot of wear for a few days while it is wear hardening. Then the amount of wear decreases. The friction of the rock being crushed plus the abrasion wears the dies. Abrasion increases with the silica percentages in the rock as well as the flint, chert, and other abrasive metals. Most jaw dies are 12% manganese content. CEC's jaw dies are 14%, and some special dies for high abrasion go up to 16 to 18%. 14% manganese is considered premium content. Now let's look at the job we have to do. We do not have a used jaw, so we will imagine that the dies, protection plate, and cheek plates need to be removed and replaced. First, we will open the jaw setting to 4 or 5 inches, so we have some room to work. This is also shown on the adjustment video. Next, remove the cheek plate. Remember that the cheek plate both centers and key locks the stationary die. Cheek plates come with lifting hooks and lifting holes on the smaller sized jaws. On the larger sized jaws, you'll need to weld a pair of lifting eyes on the cheek plate. Hook a lift chain on the lifting eye, take up the slack, and apply lifting force. Use a crowbar and a 4-pound hammer to break the cheek plate dirt seal that could stop its removal. Once the first cheek plate is free, remove it and set it aside. Repeat the procedure to pull the second cheek plate. Removal of the pitman protection plate is the first step in disassembly and removal of the movable die. Weld on your lifting eyes. Always weld 2 eyes. Remove the top T-bolts, attach your handling chains, and lift the protection plate out. It sits on top of the wedge and is locked by the T-bolts. Shim the movable die so it cannot move when you remove the wedge. Go to the back of the pitman and remove the nuts for the T-bolts and spring assembly. The jaw die wedge is now loose. Remove it. Please note, jaw wedges on jaw sizes 30 by 42 and larger are more than one man can handle. Use lifting eyes and additional help. Weld lifting eyes onto the movable die. Next, attach your spreader chains to the movable die. Remove the die and set it aside. Inspect the pitman surfaces and die seats. If you find wear on the seat, call the CEC factory or your dealer for proper build-up procedures. We are now going to remove the fixed die. Unbolt the wedge at the top of the jaw. Block the die so it cannot move during wedge removal. With the bolt removed, pry the wedge loose and remove it. Weld on the lifting eyes. Take up the slack in your lift chains, remove your shim block, and lift the stationary die out of the crusher cavity. Set it aside. You will need to clean up all of the seating surfaces and check them for wear and flatness. Jaw dies cannot move when crushing, and the seating surfaces must be in good repair for them to lock in place. Check all die seats and clean them. Clean the backing surfaces so the dies can seat properly. Now let's start our reassembly. First, install your fixed jaw die. Hook up the chains and lift it into place. Block the die so it cannot move while you install the wedge. Center the die and make sure it is seated. Install the wedge and wedge bolts. Fixed dies do not use springs. Only tightening nuts and lock nuts are used. Remove the block. Reinstall the movable die. Pick it up and let's look at the lift method. Remember to always use 2 lifting eyes. The chain should be fastened to the lifting hook and to both lifting eyes. If either eye weld fails, we would not drop the die. It might take a quick and sudden swing, so keep yourself clear of the die during handling. CEC, your employer, and your family don't want you or any of your coworkers injured. Follow good proven safety procedures. Ask your supervisor if you have any safety questions. Do not try to shortcut good, safe procedures. Lift the jaw die into place and lower it into the jaw cavity. Center the jaw die on its bottom seat. Rock it back against the pitman face and block it against the pitman. Block the die so it will not move. This allows you to release it and start on the next item. Install the wedge bolts, springs, and nuts. Tighten them and use a hammer to pound the wedge to make sure it is seated. Next, pick up the pitman protection plate and lift it into place. Install the T-bolts and tighten them. Use your big hammer and check to make sure you have this seated. Then retighten. The pitman protection plate is in line with the jaw die's top surface. It is a wear part and protects your pitman bearing housing from wear. Jaws that do not have protection plates get wear on the pitman faces and require buildup. This is not good because you have the chance of arc welding your bearing rollers to the cages of the bearing. Look at the flat plane of the protection plate to the jaw dies. CEC jaws do not have that round surface of the pitman restricting the feed opening. This allows CEC jaws to take a larger feed size. We like to say CEC jaws do not have beer bellies. With the dies installed, it's time to install the cheek plates. Lift the cheek plate into position. Lower it in its guides and pound it down. Install T-bolts, washers, and nuts. Snug it down, pound it down tight in its seat, and retighten. Repeat the process on cheek plate number 2. Note, any T-bolt that has a top surface extended above the wedges or protection plate needs to be ground down flush. The bolts will wear with the dies, but they will break if left high to start crushing. When reassembly is completed, cut off all of the lifting eyes. In order to ensure that you do not get any bolt stretch, you'll need to retighten the bolts after the first day of operation, plus 2 or 3 times in the first week of operation. Readjust the jaw to the run setting and go to work. If you have any questions on installation, please don't hesitate to call CEC's Service Department. We want to be your partner in good performance. Screens. Screens are used to separate rock products by the size of the cloth installed. If the product can fall through the screen cloth, it moves to the next level. If it does not fall through, it exits off the discharge lip. The CEC screen shown here is a 5x12 screen. It consists of the following parts: screen basket, screen suspension and support, eccentric mechanism and drives, drive guards, and subframe. This screen is a customer's unit to be installed on an existing crusher. It replaces a vibrating feeder. The top screen lip will feed the crusher. The second lip will feed the bypass chute, and the throughs or reject will exit the underconveyor. Look at the frame structure and channel frame mount. This will slide onto the customer's crusher frame and bolt down. It will require minimum adaptation. The frame is complete with access ladders, walkways, railings, and kick plates. CEC makes two types of screens: a welded construction style up to and including the 5x14 size, and a huck riveted style with replaceable decks on the 5x16 and larger sizes. CEC makes screens from 3 feet by 6 feet to 6 feet by 20 feet in size. Now let's look at the screen basket. It's a welded construction, and the cross members are the screen deck supports. The screen has a special step deck to cause a tumbling and cleaning action as it screens. All CEC screens have feed boxes for the material to enter and take the impact off the screen cloth. They have discharge lips to feed chutes. This screen has special purpose, customer-required discharge lips. Next, let's look at the screen suspension system. CEC uses Firestone vertical rubber coiled spring mounts. These are sized for the particular screen weight and loading. The rubber screen mounts maintain the ability to rebound under maximum load, unlike coil springs. The coils press closer together, bottom out from the weight, and lose their bounce back. CEC also uses corner mounts on all of its screens. The mounts bolt to the screen sidewalls and subframes with steel plates. In between the plate and vulcanized to the plate is a rubber spring support. The support's first duty is to keep the screen in proper alignment at all times. It controls the critical vibration during startup and shutdown by minimizing the screen movement as it gains RPM or decreases RPM. This function is particularly important when screens are installed in tower steel structures. Some of CEC's competition has now started using Firestone vertical rubber spring mounts. They charge several $1,000s extra for what CEC gives you as standard equipment. The CEC screen shown in this video is an incline screen. This screen has a 12-degree screen deck slope. The screen leg length in the mounting accomplishes this slope. CEC makes 12-degree screens, 15-degree screens, and 18-degree screens. CEC also makes flat screens in 5x14 and larger sizes. CEC makes heavy-duty grizzly scalp screens for riprap or dirt separation. Now let's look at the screen eccentric. This is the mechanism that causes the screen to vibrate. CEC screens have a 45-degree to horizontal stroke. Along with the incline, this stroke causes the product to travel down the screen so the material can be separated. The screen can run at different speeds as required. CEC's eccentric system can be run at one of three speeds: 820 RPM, low speed, heavy rock; 940 RPM, medium speed, medium rock; 980 RPM, high speed, maximum separation, light rock. CEC has the ability to vary not only the speed, but also the counterweight of the shaft. This gives CEC screens the ability to increase the length of the stroke and make the screen clear even in arrow-shaped materials and compost. Change the sheaves for speed and change the counterweights for length of stroke. CEC has two styles of lubrication for the screen bearing, either running in oil or grease. 5x16 and larger screens have running and oil bearings. You can order running and oil bearings on smaller screens for an optional charge before manufacture. CEC screens, up to and including the 5x14 screen, use an adjustable shaft-mounted external counterweight to cause the stroke. Larger 6x16 and 6x20 screens use both eccentric center shafts and external counterweights. The larger screens have more mass and load than the external weights can handle. CEC screens have strokes that vary from 3/8 of an inch to 5/8 or 3/4 of an inch. The screen shown in this video is the famous Screen It screen and will be running at 5/8 stroke to provide good material feed and product clearing. The second deck of the screen shown has square 1.5-inch cloth installed. The top deck of the screen will have steel plate, 1/4 inch thick with 3-inch round holes. Now let's talk a little about the installation of screen cloth. The clamp rails that hold the cloth in position must pull the cloth tight from the center out to each of the sides. It's possible to have the clamp rail bolts as tight as you can turn them and still not have the cloth tight. Here's a walkthrough of the proper installation procedure. Check all of your crown bar rubber to make sure it's in good working order. Check the crown bar to make sure you don't have any mechanical problems. Example, look for bad wear patterns. Make sure the clamp bar bolts are straight and that the holes are clean and clear. Drop the screen cloth on the deck and check it for proper forming dimension. Screen cloth has a manufacturer's recommended forming width outside of hooks, normally referred to as OSH. This screen has a recommended forming width of 58.5 inches OSH. The difference between the inside of the basket of 60 inches and the 58.5 inch OSH gives you clamping room and allows for cloth stretch. Now let's talk about clearance. Most screens are made for standard wire size. When you go to heavier wire gauges and/or banded wire, you could as much as double the thickness. This new thickness can stop your clamp rails from breaking over the closing arc, so you can tighten the cloth. The clamp rail bolts pull tight, but you've created a new problem. The clamp rail drives down on the screen cloth banding and extra thickness. This bottoms out on the solid steel underclamp bar wedge and causes the bolt to pull tight and the mass to be locked solid. Your first impression is that your job is done. Not so. Your cloth is still loose. You need to remount the clamp bolt wedges to allow additional bolt travel until the rail breaks over. Or you can install a shorter-legged clamp rail for heavy-duty cloth application. CEC can make this for you as a special order. If you're breaking screen cloth down the center of the panel, it tells you that the cloth was not tight. The screen cloth will, without exception, break if it is not properly tensioned and all faces pulled tight on the crown bars. Be certain you've done this properly. It doesn't matter who manufactured the screen basket or brand of screen cloth. If the cloth is not fit properly, it will break. You can have the bolts tight, the clamp rail bottomed out, but still be loose in the center. You think you're okay, but in a few hours your cloth will be ruined. The correct operation is with the rails over center and cloth properly tightened and snug on the crown bars. It's easy to change the cloth size, banding, and screen wire diameter, thereby causing yourself a problem that was not a problem before the change. Look at the ends of the clamp rails and make sure they're over center. Your screen cloth supplier will not replace cloth that is broken down the center. He knows what has happened as soon as you tell him where the cloth failed. Now let's take a look at CEC's drive mechanism. CEC motors mount off the subframe and have a bolt tensioner to adjust the belts. CEC uses multi-groove sheaves and #1 quality belts. Changing the motor sheaves can vary screen speed. Do not do this change without CEC direction. Overspeed combined with improper counterweight combination can cause premature bearing failure or mechanism damage. All CEC screens use cast steel machined bearing housing and special screen bearings to assure good life and easy service. The drives are enclosed and the counterweights are guarded. CEC screens are always supplied with subframes that facilitate the CEC rubber suspension system and motor drives. CEC does not use a pivoting motor base. Like several other major manufacturers, CEC uses an offset taper lock in the screen drive bushing to compensate for screen stroke movement. They're much less trouble than spring-loaded tables. The complete screen module is easy to install, comes with underhopper, under conveyor, walkway, railing, kick plates, guards, crown bar rubber, motor, drives, and drive guards. It comes with mounting channels ready to bolt in place. Special discharge lips are not a problem, as long as we get good information from the customer. Remember, your screen is only as good as your maintenance. Lubricate the screen according to your manual. Keep the belts properly tightened and in good shape. Do as we recommend, and you will have long, trouble-free service. Safety first is CEC's goal. With this video, CEC wants to remind you of safety first. The following are points you must always consider. Always lock out the power source to the crusher you're working on. First, remove the engine key and put it in the pocket of the man who will be doing the work. Second, lock out the electric switchgear with a padlock and put the key in the pocket of the man doing the work. This procedure will help avoid the chance of a false startup of equipment that could, in turn, injure the worker who is performing the maintenance on the crusher. Never operate a CEC product without first reading the operation and maintenance manuals. Read all the caution and advice labels on your machine prior to operation. The labels are placed on the plant for your protection and for your fellow workers. Inform your fellow workers and all new workers of the safety requirements of the CEC equipment. Never make adjustments to any CEC machine while it's running. This avoids getting clothing caught in moving parts and possibly being pulled into the machine. Never try to remove anything from a crusher while it's running. It's very dangerous. You need to stop the crusher completely and lock out before trying to remove unwanted input items. Review your machine setup. Add safety guards to any area your setup would need to provide a safe work environment for your workers. Safety first is CEC's goal.
There are potential dangers involved in the use of heavy construction equipment. As properly trained operators know, for instance, you should take the time to check behind your machine before backing heavy equipment. Many times it's necessary to have a spotter visible in your mirror to help you safely maneuver backwards. You should also be sure, of course, that your vehicle safety belt is fastened and that your backup alarm is working properly. But apart from the specifics of heavy equipment operation, there's a whole other area of accident prevention, and that has to do with keeping the machines in top form.
Proper maintenance of construction equipment is necessary to prevent serious injuries and in preventing huge property losses and unnecessary expenses caused by delays. Records show that all too often, the condition responsible for injuries and job delays is improper maintenance or no maintenance at all. Sometimes these maintenance problems come with the misuse of construction equipment, which can be the result of insufficient operator training. And other times, it's simply lack of attention to normal maintenance procedures.
Most manufacturers of heavy construction equipment have maintenance and inspection manuals, and operators should familiarize themselves with them for each machine they operate. For example, Periodic maintenance of a crane would include checking the condition of the sheaves, bearings, and cables, as well as the clutches and the brakes. This is actually just a few of the crane's many items you would need to service. A checklist for a scraper should include the hydraulic system, the bowl, and ejector. Good tire tread and air pressure should be maintained, and the steering and brakes should be tested regularly. And the bulldozer would have its own set of requirements. You'd have to check things like the track adjustment, pins and bushings, the blade control, and the backup alarm. Notice that along with keeping a regularly scheduled inspection, you should maintain an accurate log of when each inspection is made, as well as the results and conclusions of those inspections.
This is just a very quick cross-section of possibilities to serve as an example of the kind of things you'd find in the maintenance manuals. And apart from these specific maintenance requirements, there are several common-sense safety rules for maintaining the equipment. You need to protect the equipment from weather, fire, blasting, and vandalism. For instance, you should store smaller equipment indoors whenever possible to protect it from the weather and potential vandalism. For things that can't go inside, they should definitely be stored away from any potential explosive source, such as gasoline tanks, oil and grease containers, and compressed gas cylinders. For the same reason, gas-powered equipment should be stored away from potential fire hazards, such as dry grass and brush areas, old wooden forms, and oily rags. And as I mentioned, always keep heavy fuel-powered equipment away from blasting activities. And remember, always use inspected and approved equipment. You know you need to be careful on a job involving a piece of heavy machinery. Any accident is bound to be a major one. So protect yourself and your coworkers. Keep up with the proper maintenance and take care of how and where you store your heavy equipment. The last thing you want is for a machine of this size to malfunction on you.
Thank you for watching this CEC video.